Good morning, students. Today we are just revising these portions. Universal law of gravitation. Here, first itself, they given the definition of universal law of gravitation. Every object in the universe attract every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. Okay, that's the definition. The force is along the line joining the centers of two objects. Uh, okay, only definition is every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. The force is along the line joining the centers of two objects. Okay, force is along the line joining centers of two objects. Okay, in here centers of A and B. Okay, the equation is given here. F is equal to G. F is equal to G into M divided by D square. Okay, how this equation came? Okay, we will discuss that. According to universal law of gravitation, the force between two objects are directly proportional to the product of their masses, or force is directly proportional to mass. In previous case also we studied force is directly proportional to mass. F is equal to ma. In that, force is directly proportional to mass. Here two objects are there, so force is directly proportional to product of that masses. Then the force between two objects inversely proportional to the force between two objects inversely proportional to the square of the distance between them. F is equal to 1 by d square. Okay, how this 1 by d square or square, inverse square came there? Okay, that is explaining here, but you no need to study that derivations and all, but it's explained here for better understanding. If you study this, you will make more confusion, but we will explain that. Okay, no need to study that, but you have to understand that's it. Here, this is a Kepler's law. Kepler's law, you can read that. In that Kepler's law, there's one equation: r cube by t square is equal to a constant. In Kepler's law, r cube by t square is a constant. Okay, then we will come to our law. Okay, force acting on the orbiting planet is given by F is directly proportional to V square by R. F is directly proportional to V square by R. Okay, V square by R. If T denotes the period, then V is equal to 2 pi R by T. Okay, T is the time period, then V is equal to, velocity is equal to 2 pi R by T. 2 pi R is the circumference of the circle, then by T we will get velocity. Okay, here V is equal to 2 pi R by T. So that we already studied in that circular motion, the velocity, how will come 2 pi R by T. Okay, so that V square is directly proportional to R square by T square. Here V is equal to 2 pi R by T. In 2 and pi are constant, so make that proportional, then that constant we can remove. We will make equation, then that constant we add, that's it. So we can say V directly proportional to R by T. So here we are taking V square, so V square is directly proportional to R square by T square. Okay, R by T whole square, so R square by T square. Then we can rewrite this equation. What we did in that, R square by T square into R by R, we did R by R. In that R we take in that R square, then R cube by T square into 1 by R. R by R, we added R by R, we multiply with r by r, then the value will not change, because uh, both side we are adding r, so the value will not change. So we can rearrange that equation, 1 by r into r cube by t square. So we can rewrite v square directly proportional to 1 by r into r cube by t square. R cube by t square is a constant. There Kepler's law we studied. We understood. Okay, Kepler's law already. We are not studying that, but already they mentioned it's a constant. Kepler mentioned that. Okay, we have v square is directly proportional to 1 by r. V square is directly proportional to 1 by r. Combining with this, f is directly proportional to v square by r. Here f is directly proportional to 1 by r square. V square is directly proportional to 1 by r. So v square by r is r, we can write 1 by r into 1 by r. So 1 by r square. Okay. V square we can give 1 by r, then 1 by r square you will get. So that f is directly proportional to 1 by r square. R is the radius of that circle. So we will get f is directly proportional to 1 by r square. That is a inverse square law. This inverse square law we are using, so that here Newton used that, so that we got f directly proportional to 1 by d square. Okay. Then combining equation 10.1 and 10.2, force is the product of mass of two objects, and force is inversely proportional to the square of the distance between them. Then we will get f is directly proportional to m into m by d square. Then that proportionality sign we are changing to equation. Then f is equal to g into m divided by d square. G is a constant, and it is called a proportionality constant here. In proportionality constant in a gravitation, so it is called a universal gravitational constant. Gravitational constant. Okay. Then we are rearranging that. D square is going to other side. F into d square is equal to g into m into m. Then g only g want to keep there. Then m into m is going to the next side. Then we will get g is equal to f d square by m into m. It's for calculating the value of g. Okay, it's for calculating the value of g. Here Henry Cavendish, a scientist, a great scientist, Henry Cavendish is calculated the value of g. Then that value is 6.673 into 10 raised to minus 11 Newton meter square by kg square. 6.673 into 10 raised to minus 11 Newton meter square per kg square, or kg raised to minus 2. You can write like that also. Okay, that only here they are saying. And inverse square, in more to know that box, they are saying inverse square. Okay, inverse square, they are saying force is inversely proportional to the square of the distance. Means, for example, that if d gets bigger by a factor of 6, okay, if d get bigger factor like 6, if it is a 10, then it makes more number, or if it is 6, then force is directly proportional to 1 by d square. So d is 6, then the value will be f is directly proportional to 1 by 36. Okay, 1 by 36. 1 by 36, so that much smaller value. Force will get that much smaller value. So here itself you can see that in that equation. Okay, If you consider d is 6, then F is equal to g into m divided by d square. That is, F is equal to g into m divided by 36. That is 36 times smaller than. That is square. If it is not 6, if it is 5, then F is equal to g into m divided by 25. 25 times smaller. If the distance is 1 unit increase, then its square times it will increase. Okay, that is 5, then it will be 25 times lesser. Then if it is 6, then it is 35 times lesser. If it is 7, then it is 49 times lesser. Okay, that's a difference, not 6 times, 7 times or 5 times. It's a square times is lesser. The force will lesser in square times. Okay, then here one calculation is given. We are calculating the mass of the earth is given 6 into 10 raised to 24. Already we did that. And that moon is 7.4 into 10 raised to 22 kilogram. Okay, the mass of moon is 7.4 into 10 raised to 22 kilogram. Mass of earth is 6 into 10 raised to 24 kilogram. The distance between the earth and the moon is 3.84 into 10 raised to 5 kilometer. 3.84 into 10 raised to 5 kilometer. Okay, 3,84,000 kilometer. Calculate the force exerted by the earth on the moon. Calculate the force exerted by the earth on the moon. Okay, in moon, how much force exerted from earth? Okay, that we have to see that. Okay, calculate the force exerted by the earth on moon. Okay, മൂണിൽ എത്രത്തോളം ഫോഴ്സ് എർത്ത് എക്സേർട്ട് ചെയ്യുന്നത് അല്ലെങ്കിൽ എത്രത്തോളം ഫോഴ്സ് അപ്ലൈ ചെയ്യുന്നുണ്ട്, ഗ്രാവിറ്റേഷൻ പുള്ളുണ്ട് എന്നുള്ളതാണ്. എത്രത്തോളം ഗ്രാവിറ്റേഷൻ പുള്ളുണ്ട് എന്നുള്ളതാണ്. Okay, we will calculate that. The mass of the earth m is equal to 6.10 raised to 24 kilogram. The mass of the moon is 7.4 into 10 raised to 20 kilogram. Already we know the distance. Already we know 3.84 into 10 raised to 5 kilometer. In kilometer we will make that meter. If you are making that meter, then we need to add or multiply with 1000. Okay, if it is kilometer, then we want to add or we want to multiply with 1000. We will get meter. How much meter that? We want to multiply with 1000. That's it. Okay, 1 kilometer is 1000 meter. So we want to multiply with 1000. So we will get 3.84 into 10 raised to 8 meter. Then the value of g we know 6.7. Here is given 6.673. Then that 6.673 we are rounding. Then 67 we are rounding and making 7. 6.7 for simplify the calculation. That's it. Okay, 6.7 into 10 raised to minus 11 Newton meter square per kg square. Okay, then the force exerted by the earth on the moon is F is equal to g into m divided by d square. In that 6.7 into 10 raised to minus 11 Newton meter square per kg square is g into mass of two product. One is mass of earth 6 into 10 raised to 24 and mass of moon 7.4 into 10 raised to 22 kilogram by 3.84 into 10 raised to 8 meter all square. Okay, 3.84 into 10 raised to 8 meter all square d square. Okay, then we will get calculating that value, we will get 2.02 into 10 raised to 20 Newton. That Newton 10 raised to 20 Newton, that force exerted by the earth on the moon is 2.02 into 10 raised to 20 Newton. Then here two questions are given. State the universal law of gravitation. State the universal law of gravitation. What is universal law of gravitation? Every object attract each other and it is directly proportional to the product of the masses and inversely proportional to the square of the distance. Okay. Okay, and force is along with the center of that two objects. Okay. Importance of the universal law of gravitation. Okay, why this universal law of gravitation is important? It can explain so many factors, so many phenomena. Okay, so many phenomena we can explain with this universal law of gravitation. Okay, that can explain the force that binds us to the earth. We are standing in earth. Okay, we are standing on earth. That can explain by gravitation. Okay, the motion of the moon around the earth, the motion of the moon around the earth, we can explain it is orbiting circular motion, and it is not going far from earth. That orbit do not violate that orbit. It is due to gravitation. And motion of the planets around the sun. All planets are that means a solar system. In solar system, that all planets are orbiting the sun in a particular path, that due to the gravitation. And the tides due to the moon and the sun. In the influence of the gravitation from moon and sun, the tides will happen in oceans, seas. There is a low tide and high tide. Low tide and high tide. Okay, that means in Malayalam, വേലിയേറ്റം വേലിയിറക്കം. Okay, low tide and high tide. അതായത് കരകളിലേക്ക് വെള്ളം കുറച്ച് കയറി വരുന്ന അവസ്ഥയാണ്, കടലിൽ വെള്ളം ഇച്ചിരി കയറി വരുന്ന അവസ്ഥയാണ് ഹൈ ടൈഡ് എന്ന് പറയാം. വെള്ളം കടലിലേക്ക് കുറച്ചുകൂടി ഇറങ്ങി പോകുന്ന അവസ്ഥയാണ് ലോ ടൈഡ് എന്ന് പറയാം. ഓക്കെ, അതിനെയൊക്കെ എക്സ്പ്ലെയിൻ ചെയ്യാനായിട്ട് എന്തുകൊണ്ട് സാധിച്ചു? ഗ്രാവിറ്റേഷൻ കൊണ്ട് സാധിച്ചു. ദാറ്റ്സ് ദി ഇമ്പോർട്ടൻസ് ഓഫ് യൂണിവേഴ്സൽ ലോ ഓഫ് ഗ്രാവിറ്റേഷൻ. ഓക്കെ, യു വാണ്ട് ടു സ്റ്റഡി ദാറ്റ് പോയിന്റ്സ്. 4 points you want to study. That's it. Okay. Free fall. Free fall, you can read that portions. There is nothing more to say. There is a body is falling down to the earth only by the force of gravitation. Only by the force of gravitation. Okay. Here we can say, yeah, whenever object falls towards the earth under this force alone. Okay, it will come now. Whenever objects falls towards the earth under this force alone, which was gravitational force, we say that objects are in free fall. We say objects are in free fall. Changing the velocity of falling objects. Yeah, obviously changing the velocity of falling objects. Okay, that velocity change happens due to free fall is called acceleration. In case of motion, we call it acceleration. In the case of gravitational motion, we are saying acceleration due to gravity. Due to gravity. Acceleration due to gravity. Okay. Whenever velocity involves acceleration, whenever an object falls towards the earth, an acceleration involved. This acceleration is due to the earth gravitational force. Therefore, this acceleration is called acceleration due to the gravitational force. So, acceleration due to gravity. Okay. This we can represent G, small letter G. Okay, it's important. Small letter G. Capital letter G is the universal law of gravitational constant. Capital letter G is universal law of gravitational constant. Okay, you can say universal gravitational constant. Okay, here small letter G is acceleration due to gravity. Don't be confused or don't make mistakes for calculation. Okay, we know the second law of motion, the force is the product of mass and acceleration. Second law we studied, F is equal to ma. Force is equal to mass into acceleration. Mass into acceleration, ma. Let the mass of the stone activity 10.2. 10.2, where's that 10.2? Okay, there is a 10.2 activities is there. That activity is saying take a stone, throw it upwards. It reaches a certain height and then it starts falling down. Here, a stone is thrown upwards, then it's start to come down. It's in the top. It's in the top. The velocity will be 0 because it start to falling down. Okay. Then it reaches a certain height and then it starts falling down. Okay. In this activity, if you throw a stone above, then it reaches a certain height, it will come back. Okay. Then where okay. Let the mass of the stone in activity 10.2 by m. Okay, in that object mass m, we will calculate m, small letter m. Okay, we already know that there is acceleration involved in falling object due to the gravitational force and denoted by g. Okay, acceleration involved. If it is comes down, its acceleration involved, and that acceleration is denoted by g, small letter g. That g is called acceleration due to gravity. Okay, then F is equal to the product of masses and acceleration. F is equal to the product of mass and acceleration. That is F is equal to ma. In that a we replaces with g because is falling down. That stone is falling down. Then this acceleration is due to gravity, so that acceleration we can represent g. Okay, then force is equal to mass into acceleration, mass into acceleration due to gravity, mg 10.6. Then from equation 10.4 and 10.6, that universal law of gravitation, F is equal to g into m divided by d square. In that F replaces with m into g. Okay, F is equal to mg. So mg is equal to g into m by d square, or g is equal to g into m by d square. That smaller term is the weight of mass of stone. So that m is coming to this side, right side. Then smaller m, both smaller m are cancelled each other. So g is equal to g into capital M by d square. Capital M is the mass of earth. Okay, m is the mass of earth and d is the distance between the object and the earth. Then we can calculate that equation. Mg is equal to g into m by r square. G is equal to g into m by r square. That r square is the radius of the earth. If an object is the surface of the earth, then we can say the distance between that object and earth is radius of the earth, because the object is in the surface. Okay, object is not far from earth, it is in the surface of the earth. So we can calculate the distance. This distance is distance from center of the earth to surface of the earth. That we already calculated, or we know that value. So we can do that calculation simply. We are neglecting the distance. If I am in a one-story building, then that distance, one-story building distance, neglecting, and it is very negligibly 0 compared to the radius of the earth. So we are taking that distance is radius of the earth. Okay, here r square given, so g is equal to g into m by r square. Then earth is not a perfect sphere. This is very important, that we can discuss after this calculation, I think. Okay, then we already studied g is equal to g into m by r square. G is 6.7. Capital G is 6.7 into 10 raised to minus 11 Newton meter square kg square. Mass is 6 into 10 raised to 24 kilogram, and radius of the earth is 6.4 into 10 raised to 6 meter. We already got every values. Then you have to apply that. That's it. 6.7 into 10 raised to minus 11 into 6 into 10 raised to 24 by 6.4 into 10 raised to 6 meter all square. Okay, you have to square that. Then you will get, finally you will get 9.8 meter per second square. Okay, that is the value of acceleration due to gravity on earth. എർത്തിൽ ആക്സലറേഷൻ ഡ്യൂ ടു ഗ്രാവിറ്റി എന്ന് പറയുന്നത് 9.8 മീറ്റർ പെർ സെക്കൻഡ് സ്ക്വയർ ആയിരിക്കും. ഓക്കെ, അപ്പോൾ ഇനിയിപ്പം ഒരു വസ്തുവിൻ്റെ മാസ് തന്നിട്ട്, ഒരു ഒബ്ജക്റ്റിൻ്റെ മാസ് തന്നിട്ട് അത് ഫോൾ ഡൗൺ ചെയ്യുകയാണെങ്കിൽ അതിൻ്റെ ഫോഴ്സ് എത്രയായിരിക്കും എന്ന് ചോദിച്ചു കഴിഞ്ഞാൽ എന്ത് ചെയ്താൽ മതി? എർത്തിലുള്ള ഫോഴ്സ് ചോദിച്ചാൽ എന്ത് ചെയ്താൽ മതി? മാസ് ഇൻറ്റു ആക്സലറേഷൻ ഡ്യൂ ടു ഗ്രാവിറ്റി, ദാറ്റ് ഈസ് 9.8 മീറ്റർ പെർ സെക്കൻഡ് സ്ക്വയർ. ഓക്കെ, അങ്ങനെ ചെയ്താൽ മതി. ഹിയർ ദ എർത്ത് ഈസ് നോട്ട് എ പെർഫെക്റ്റ് സ്പിയർ as the radius of the earth increases from the poles to the equator. Equator is what if we say that ball, we know poles, north pole and south pole. Okay, in that north pole and south pole the radius is lesser than the radius from the equator. Okay, radius of the equator is bigger than the radius from poles to center of the earth. Okay, poles to center of the earth. It is due to in poles somewhat flatter, and that earth shape is geoid. It is not a perfect sphere. Okay, so poles are somewhat flatter, and that also is very low value. Okay, it is not a higher difference but low value. So you will get in poles the radius is less. Radius is less means g will be high. Radius is less means g will be high because g into m by r square. R square is down, so inversely proportional. So inversely proportional means lesser. That r square is increasing, then the value will be lesser. Okay, so in the equator we will get 9.8, in that poles we will get 9.9, but in the case of earth we are taking 9.8 itself. Okay, if we are doing the calculation 9.8, but where there's question may happens, last year annual exam also that question asked. That question is there any difference in acceleration due to gravity in poles and equator, or every parts of the earth is acceleration due to gravity is same? Justify your answer. Then you have to know that point. Poles, the radius of center to pole is lesser than radius of center to equator. Okay, that you got, I think. Then motion of the objects under the influence of gravitation force earth. Then nothing. We know three equations of motion, that is v is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. Okay, these are the three equations of motion. This is very important. Previous class this equation discussed. This equation is important for calculation in gravitation as well as motion. Okay, in the case of chapter motion and gravitation, these three equations are important. You should study, you should by heart these three equations, and every terms you have to know. Okay, and you will be flexible. You should flexible with the rearranging these equations. If here v is equal to u plus at, there we want to calculate a, then how we will rearrange that? V minus u by t is equal to a. We have to rearrange, that's it. Okay, we should study how to rearrange that. We try it, then you will get it. Okay, then there is one question based on acceleration due to gravity. Here that question is given. In that, first we will use a core falls off the ledge and drops to the ground in 0.5 seconds, let g is equal to 10 meter per second square. 9.8 meter per second square, that we will calculate 10, we will take that for calculation. Okay, it's for simplifying the calculation. 10 is around, making round, that's it. 10 meter per second square. What would be the speed of striking the ground, on striking ground? What is the average speed of during 0.5 second? How high is the ledge from the ground? If this question, if you are seeing this question and you know these three equations, you will be wonder how you will answer. And I have only gravitational acceleration due to gravity and only the time. There is nothing else I got. Then how I will do? You will wonder, but it is very simple. We know the equation v is equal to u plus at. Then a car is in ledger. That car is in ledger means that is in rest. Okay, rest position, the velocity will be 0. Initial velocity will be 0. Initial velocity 0. So v is equal to u plus at. That u is 0. So v is equal to at. V is equal to at. A is, what is A? A is acceleration due to gravity. That is 10 meter per second square or 9.8 meter per second square if you need accurate. Then into 0.5 seconds is equal to 5 meter per second. 5 meter per second. The next one, what is the next point we need to study? What is average speed during 0.5 seconds? In 0.5 seconds, what is average speed? U plus v by t. U plus v by t. Initial velocity plus final velocity divided by 2. Initial velocity is 0 and final velocity is 5 meter per second. We already got. We already calculated that speed. Okay. That is actually velocity. You can give that velocity. Okay. Not a speed. Okay. Actually here we are calculating velocity, here we are calculating speed. Okay, then you can write the speed itself, approx. Then average speed already we got 2.5 meter per second. That means initial velocity 0, final velocity we calculated here. Speed of that object is 5 meter per second. So 2.5 meter per second. Distance traveled, s is equal to half at square. Distance traveled. In here, in this equation, two equations have distance. That is, s is equal to ut plus half at square divided by second one, v square is equal to u square plus 2as. These two equations have s, that distance traveled. Then which equation we will use? We can use the first equation because time already given. Time already given in the question. So we can use the first equation. In first equation, what will get? If we use that ut is, u is a 0. U is 0, then 0 into any 0 into 5, then is 0. Okay, 0 into any value, then it will be 0. Okay, multiply with 0, then you will get 0, any value. Then s is equal to half at square because ut is 0. Then half at square, half into a is gravitational acceleration due to gravity, then that we can represent g, that is 10 meter per second square, into 0.5 second all square, at square, all square. So half into 10 raised to meter per second square into 0.25 second square and second raised to minus 2 cancelled out. So 1.25 meter is the distance travelled. So you can rewrite the values. The speed of striking ground is 5 meter per second. Average speed of 2.5 meter per second. Height of the ledge is from the ground 1.25 meter. You got the answers. Okay, another one also is given here. That you just check. If you are not understanding, you just comment in WhatsApp. Then we will discuss that. Okay. Next one is mass and weight. That before that, I have one question. You are going to shop, then you are asking, give me 1 kilogram rice, and you are taking somewhat rice, then coming back to home. My question is, that is 1 kilogram. Okay, that is 1 kilogram rice or 1 Newton. Next time you go to shop, then you ask to them, give me 1 Newton rice, then they will be shocked because we used a gram. Okay, and kilogram is a unit of mass. Kilogram is a unit of mass, and unit of weight is Newton. Unit of weight is Newton, and you are getting the weighing mass or weight. You are getting a weighing object. If you are taking rice or vegetables, whatever, you are getting weighing object. Okay, and you are getting a weighing value, that is weight. We are getting the weight of that object. If we are calculating 1 kg rice, that is actually 1 Newton rice, not kg. Okay, mass, the unit of mass is kilogram and unit of weight is Newton. Okay, then what is mass? Mass is nothing but the amount of matter present in the object. The amount of matter present in that object. If we are taking a object, that object have particular amount of matter. That means if we are taking water, H2O, that H2O have H2O molecules, that water have H2O molecules, lot of H2O molecules are there. That H2O molecule have its mass, and the total mass of that water is constant if you are calculating in earth or moon or sun, whatever it, because it is the amount of matter. The mass is the amount of matter present in that object. Okay, that is if we are considering water, then H2O molecules. The mass of the H2O molecules present in that water is mass. And what about weight? Weight is the force exerted by the earth. Force exerted by the earth. Okay, that means force is equal to mass into acceleration. So acceleration is acceleration due to gravity by earth. So you will get the weight means it is mass into acceleration due to gravity. In earth the acceleration due to gravity is 9.8 meter per second square. But if you keep this if you are weighing here, you will get if my case I am 68 kilogram. Okay, 68 kilogram, but consider 60 kilogram. Okay, 60 kilogram. Then if I go to moon, and there also TRAS is there, that weighing machine is there, then I will use to check my weight, then I will get 10 kilogram. 10 kilogram. Why it is happen? Because there the acceleration due to gravity is smaller, very smaller than earth, and the acceleration force is very smaller there. That's why our weight is lesser in moon. So weight is nothing but the acceleration pull of a object. Okay, and mass of that object, that amount of matter present in that object, and the acceleration pull. So if you weigh a object in earth, that weight is the object in earth, not from other planets. If you keep that object in other planets and weigh it, then the weight will be varied. Is based on the gravity present in that planet. Okay, that is weight. Weight is dependent on the gravity. So F is equal to ma, then weight is equal to mass into acceleration due to gravity. So you will get W is equal to m into g, that is equal to, you will get unit Newton. Okay, if it is 10 kilogram mass, then in earth you will get 10 into 9.8, 98 Newton. 98 Newton is the weight. Here mass, we already discussed that mass is the amount of matter present in that substance is called mass. Amount of matter present in that substance called mass. Okay, that's the definition of mass. Then here it's more much simplifier for you, because you studied inertia, that's why they are much simplifier here. Mass of the object is the measure of its inertia. Okay, measure of its inertia. നമ്മൾ പറഞ്ഞു കഴിഞ്ഞു മാസ് കൂടിക്കഴിഞ്ഞാൽ അതിൻ്റെ ഇനേഷ്യ കൂടുതലായിരിക്കും എന്ന് പറഞ്ഞു. അതായത് ഒരു വസ്തു നിലത്തിങ്ങനെ റെസ്റ്റ് ചെയ്തിരിക്കുകയാണെങ്കിൽ നമ്മൾ അതിനെ തള്ളി നീക്കാനോ അല്ലെങ്കിൽ നമ്മളതിനെ എടുത്ത് നമ്മളതിനെ ഉയർത്താൻ വേണ്ടി എടുക്കുന്ന ഫോഴ്സ്, അതാണ് എന്ത്? മാസ്. അല്ല, അത് സോറി, ഉയർത്താൻ വേണ്ടി എടുക്കുന്ന ഫോഴ്സാണ് വെയിറ്റ്. ഓക്കെ, അപ്പോൾ ഇനേഷ്യ ആയിട്ടുള്ള, അല്ലെങ്കിൽ ഇനേഷ്യ എന്താണ്? ഒരു സ്ഥലത്ത് നിശ്ചലമായിട്ടിരിക്കുന്ന വസ്തു, അത് റെസ്റ്റിംഗ് ഫേസിലുള്ള ഒരു വസ്തു, സോറി, എടുത്ത് ഉയർത്തുന്നത് എന്താണ്? അത് അപ്പോൾ ഗ്രാവിറ്റിയാണ് അപ്ലൈ ചെയ്യുന്നത്, അതുകൊണ്ട് വെയിറ്റ് ആണ്. ഇനേഷ്യ എന്താണ്? റെസ്റ്റിംഗ് ഇനേഷ്യ ഉണ്ട്, മൂവിങ് ഇനേഷ്യ ഉണ്ട്. അപ്പോൾ അതിൽ ഇപ്പോൾ റെസ്റ്റിംഗ് ഇനേഷ്യ ആണെങ്കിൽ ആ വസ്തുവിന് അവിടെ ഇരിക്കുമ്പോൾ അതിനുള്ള മൂവ്മെൻറ്റിന് സാധ്യതയില്ലാത്ത ഒരു ഇതുണ്ടല്ലോ, അതെന്താ പറയുക, അത് കൃത്യമായിട്ട് ഡെഫൈൻ ചെയ്യുവാണെങ്കിൽ നമുക്ക് ഇപ്പോൾ ഇനീഷ്യയുടെ ഇതിൽ പറയുമ്പോൾ പ്രശ്നമുണ്ട്. ഇനീഷ്യ എന്ന് പറയുമ്പോൾ തന്നെ നമ്മൾ മാസുമായിട്ട് ഡിപ്പെൻഡഡ് ആണ്. പക്ഷേ പറഞ്ഞു വരുമ്പോൾ എങ്ങനെ എക്സ്പ്ലെയിൻ ചെയ്യുമെന്ന് ചോദിച്ചാൽ, ഓക്കെ, അത് ഇനേഷ്യായിട്ട് റിലേറ്റീവാണ്, അത്രേ ഉള്ളൂ. അതായത് ഇനേഷ്യായിട്ട് റിലേറ്റീവാണ്. മാസ് കൂടുന്നതിനനുസരിച്ച് ഇനേഷ്യ കൂടും, മാസ് കുറയുന്നതിനനുസരിച്ച് ഇനേഷ്യ കുറയും. ഓക്കെ, റിലേറ്റീവാണ്. പക്ഷേ മാസ് എന്ന് പറഞ്ഞാൽ എന്താണ്? അത് ആ വസ്തുവിൽ, അല്ലെങ്കിൽ ആ വസ്തുവിലുള്ള മാറ്റർ നമുക്കറിയാം. ഇപ്പം വാട്ടറാണ് നമ്മൾ എടുക്കുന്നതെങ്കിൽ, ഒരു ഗ്ലാസ്സിൽ വാട്ടർ എടുക്കുകയാണെങ്കിൽ അതിനകത്തുള്ള H2O മോളിക്യൂൾസിൻ്റെ എല്ലാം കൂടെ ഉള്ള ആ എമൗണ്ട്, അതിൻ്റെ അളവിനാണ്, ആ അളവ് അത് എത്ര കിലോഗ്രാമാണ്, എത്ര ഗ്രാമാണെന്നുള്ളതാണ് നമുക്ക് മാസ് എന്ന് പറയാം. ഓക്കെ, അതാണ് മാസിൻ്റെ ഡെഫിനേഷൻ. അപ്പോൾ ഇനേഷ്യ, അതായത് ഇത്രേ ഉള്ളൂ, ഇനേഷ്യ റിലേറ്റ് ചെയ്യാമെന്ന് മാത്രം. അതായത് മാസ് കൂടുതലാണെങ്കിൽ ഗ്രേറ്റർ ഇനേഷ്യ ആയിരിക്കും, ലെസ് മാസ് ആണെങ്കിൽ ലെസ് ഇനേഷ്യ ആയിരിക്കും. ഓക്കെ, അത് നമ്മൾ കഴിഞ്ഞ പ്രീവിയസ് ക്ലാസ്സിൽ പഠിച്ചിട്ടുണ്ട്. അപ്പോൾ ഇനേഷ്യ റിലേറ്റ് ചെയ്തതേ ഉള്ളൂ, ഇനേഷ്യയുടെ ടൈമിലല്ല നമ്മൾ മാസ് പറയുന്നത്. അതാണ് ഇവിടെ ചെറിയ കൺഫ്യൂഷൻ ഉണ്ടാക്കിയത്. അപ്പോൾ ഇനേഷ്യയുടെ ടൈമിൽ മാസ് പറയാൻ പറ്റില്ല. നമുക്ക് പറയേണ്ടത് ഇങ്ങനെയാണ്: ഗ്രേറ്റർ ഇനേഷ്യ ആണെങ്കിൽ ഗ്രേറ്റർ മാസ് ആയിരിക്കും, ലെസ് ഇനേഷ്യ ആണെങ്കിൽ ലെസ് മാസ് ആയിരിക്കും. ഓക്കെ, അങ്ങനെ പറയാൻ പറ്റും. ഇനി അത് ഭൂമിയിലാണെങ്കിലും അല്ലെങ്കിൽ മറ്റ് പ്ലാനറ്റ്സിലാണെങ്കിലും എവിടെയാണെങ്കിലും എന്താണ്? അത് സെയിം ആയിരിക്കും. ഇറ്റ് ഈസ് സെയിം, അത് കോൺസ്റ്റൻ്റ് ആയിരിക്കും, അത് മാറുന്നില്ല. ആ ഒബ്ജക്റ്റിൽ കുറച്ച് പോർഷൻസ് മാറ്റിക്കളഞ്ഞാലല്ലാതെ, അല്ലെങ്കിൽ ആ ഒബ്ജക്റ്റിന് എന്തെങ്കിലും ഡിഫോർമേഷൻ സംഭവിക്കാതെ അതിൻ്റെ മാസ് മാറുന്നില്ല. അതിൻ്റെ മാസ് സെയിം ആയിരിക്കും, അത് നമ്മൾ എവിടെ വെച്ച് തൂക്കിയാലും. ഓക്കെ, എവിടെ വെച്ചിട്ട് അതിൻ്റെ മാസ് കാൽക്കുലേറ്റ് ചെയ്താലും അത് സെയിം ആയിരിക്കും. വെയിറ്റ് ആണെങ്കിൽ വെയിറ്റ് ഗ്രാവിറ്റേഷൻ ഡിപ്പെൻഡ് ആണ്, അതുകൊണ്ട് എവിടെ വെച്ച് നമ്മൾ തൂക്കുന്നു എന്നനുസരിച്ചിരിക്കും അതിൻ്റെ ഗ്രാവിറ്റേഷൻ എന്ന് പറയുന്നത്. ഓക്കെ, പിന്നെ വെയിറ്റ് ഓഫ് ആൻ ഒബ്ജക്റ്റ് ഓൺ ദ മൂൺ. വെയിറ്റ് ഓഫ് ആൻ ഒബ്ജക്റ്റ് ഓൺ ദ മൂൺ. ഓക്കെ, വെയിറ്റ് ഓഫ് ആൻ ഒബ്ജക്റ്റ് ഓഫ് ദ മൂൺ, അത് നമ്മൾ മൂണിലുള്ള വെയിറ്റ് കണ്ടെത്താൻ നോക്കുകയാണ്. അതായത് നമ്മളിപ്പോൾ പറഞ്ഞു വെയിറ്റ് എന്താണ്, ഭൂമിയിൽ ഉള്ള വെയിറ്റ് അല്ല മൂണിലുള്ളത്. ഇനി മൂണിലുള്ള വെയിറ്റ് എത്രയാണ് നമ്മൾ കാൽക്കുലേറ്റ് ചെയ്യാം. ഓക്കെ, വി ആർ കാൽക്കുലേറ്റിംഗ് ദാറ്റ് W is equal to G into W is a force. ഓക്കെ, ഗ്രാവിറ്റേഷണൽ ഫോഴ്സ് എത്രയാണോ അതാണ് W അല്ലെങ്കിൽ G എന്ന് പറയുന്നത്, സോറി വെയിറ്റ് എന്ന് പറയുന്നത്. അപ്പോൾ W is equal to G into M into M divided by R M square. That M is showing that moon, mass of moon, and RM square is a mass of radius of moon. Okay, radius of moon, മൂണിൻ്റെ റേഡിയസ് ആണ് RM എന്ന് പറയുന്നത്. M എന്ന് പറയുന്നത് എന്താണ്, മാസ് ഓഫ് മൂണാണ്. ഓക്കെ, അപ്പോൾ നമുക്ക് മൂണിൻ്റെ മാസ് ഇവിടെ ഉണ്ട്, റേഡിയസ് ഇവിടെ ഉണ്ട്, ടേബിളിലുണ്ട്. ആ ടേബിളിൽ നിന്ന് നമ്മൾ ആ വാല്യൂസ് അങ്ങ് എടുത്തെഴുതുക. അപ്പോൾ എന്തായി, ഒബ്ജക്റ്റിൻ്റെ അവിടെ ഇരിക്കട്ടെ, ഒബ്ജക്റ്റ് നമ്മൾ ഇതാക്കുന്നില്ല, അതായത് ഒബ്ജക്റ്റിൻ്റെ മാസ് അവിടെ ഇരുന്നോട്ടെ, അത് M എന്ന് മാത്രം കാൽക്കുലേറ്റ് ചെയ്ത് വെക്കുക. W is equal to G into M divided by R square. In that G into 7.36 into 10 raised to 22 kilogram is the mass of moon, into M divided by M is the mass of the object, okay, divided by 1.74 into 10 raised to 6 meter or square. Then you will get you want to apply the value, then you will get M is equal to 2.431 into 10 raised to 10 G into M. Okay, 10 raised to 10 G into M. In the case of weight in earth, mass of earth and mass of the radius we know. If you do that, mass of the earth and here is given mass of the earth and radius of the earth, then if you do the same calculation in the earth, that is WE, then you will get 1.47 into 10 raised to 11 G into M. Okay, then dividing this equation, you will get WM by WE, weight of moon divided by weight of earth, is equal to 0.165, approximately equal to 1 by 6, approximately equal to 1 by 6. That is, weight of the object in the moon is 1 by 6 into weight of the earth. എർത്തിൻ്റെ വെയ്റ്റിൻ്റെ 6/1 എന്ത്, ഒബ്ജക്റ്റ് മൂണിലുള്ള വെയ്റ്റ്. അതാണ് നമ്മൾ കണ്ടെത്തിയത്. എന്താണ്, എത്ര ആയിരിക്കും എന്ന് കണ്ടെത്തിയത്. അതായത് മൂണിലുള്ള വെയ്റ്റ് എന്താണ്, എർത്തിലുള്ള വെയ്റ്റിൻ്റെ 6/1. അതായത് വെയ്റ്റ് ഓഫ് ദ ഒബ്ജക്റ്റ് ഓഫ് ദ മൂൺ ഡിവൈഡ് ബൈ വെയ്റ്റ് ഓഫ് ദ ഒബ്ജക്റ്റ് ഓഫ് ദ എർത്ത് is equal to 1 by 6. And weight of the object of the earth we are taking to the right side. Then 1 by 6 into its weight of the earth. Okay, object on the earth. Then weight of the object of the moon കിട്ടും. അപ്പോൾ എത്രയാണ്, 1 by 6 into weight of the object of the moon. അതായത് 60 കിലോ അല്ലെങ്കിൽ 60 ന്യൂട്ടൺ ഇവിടെ ഉള്ള ആൾ, അതായത് എർത്തിൽ 60 ന്യൂട്ടൺ വെയിറ്റ് ഉള്ള ഒരാൾ മൂണിൽ ചെല്ലുമ്പോൾ അയാളുടെ വെയിറ്റ് എന്ന് പറയുന്നത് 10 ന്യൂട്ടൺ ആയിരിക്കും. 10 ന്യൂട്ടൺ ആയിരിക്കും. ഓക്കെ, പിന്നെ അതിൻ്റെ കാൽക്കുലേഷനാണ് വരുന്നത്. കാൽക്കുലേഷൻ നിങ്ങൾ ജസ്റ്റ് നോക്കുക, അതിൽ സിമ്പിളായിട്ടുള്ള കാൽക്കുലേഷൻസ് ആണ് കൊടുത്തിരിക്കുന്നത്. W is equal to mass into acceleration due to gravity. Simply we want to add 9.8 acceleration due to gravity. മാസ് 10 കിലോഗ്രാം ആണെങ്കിൽ വെയിറ്റ് എന്ന് പറയുന്നത് എത്രയാണ്, 98 ന്യൂട്ടൺ ആണ്. പിന്നെ അടുത്തത് നിങ്ങൾ നോക്കി വെക്കണം, മൂണിൽ എത്രയാണ് വെയിറ്റ് എന്നുള്ളതാണ് നമ്മൾ കണ്ടെത്തേണ്ടത്. അതായത് എർത്തിൽ നമുക്കറിയാമെങ്കിൽ മൂണിൽ എത്രയാണെന്ന് നമ്മൾ കണ്ടെത്തേണ്ടി വരും. അപ്പം എർത്തിൽ 10 കിലോ ആണെങ്കിൽ 10 ന്യൂട്ടൺ ആണെങ്കിൽ, കിലോ അല്ല, വെയിറ്റ് എന്താണ്, ന്യൂട്ടണിലാണ് പറയുക. ഓക്കെ, ഇറ്റ്സ് വെരി ഇമ്പോർട്ടൻറ്റ്. മാസ്സാണ് എന്ത്, കിലോഗ്രാമിൽ പറയാം. ഓക്കെ, ഇറ്റ്സ് വെരി ഇമ്പോർട്ടൻറ്റ്. അപ്പം 10 ന്യൂട്ടൺ വെയിറ്റുള്ള ഒരു സാധനം, ഒരു വസ്തു എർത്തിൽ നിന്ന് ചന്ദ്രനിലേക്ക് കൊണ്ടുപോയി കഴിഞ്ഞാൽ ചന്ദ്രനിൽ എത്ര വെയിറ്റ് ഉണ്ടാവും, 10 by 6, എത്ര, 1.67 ന്യൂട്ടൺ. ഓക്കെ, അപ്പം ഇത്രയേ ഉള്ളൂ. അതിൻ്റെ 2 ക്വസ്റ്റ്യനും ഉണ്ട്. അപ്പം ഇത്രയാണ് ഈ ചാപ്റ്ററിലുള്ളത്. നമുക്ക് ട്രസ്റ്റ് ആൻഡ് പ്രഷർ തൊട്ടിട്ടുള്ള അങ്ങോട്ടുള്ള പോർഷൻസ് ഡിലീറ്റഡ് പോർഷൻസ് ആണ്. അതിലെന്തെങ്കിലും ഉണ്ടോ എന്ന് ഞാൻ നോക്കിയിട്ട് അതിൽ ആഡ് ചെയ്യേണ്ട കാര്യങ്ങൾ എന്തെങ്കിലും ഉണ്ടെങ്കിൽ ആഡ് ചെയ്ത് തരാം. അപ്പോൾ ഇത്രയും കാര്യങ്ങളാണ് ഈ ടെക്സ്റ്റ് ബുക്ക്, ഈ ചാപ്റ്ററിൽ നമുക്ക് ഈ അക്കാദമിക് ഇയറിൽ നമുക്കുള്ളത്. അടുത്ത ചാപ്റ്റർ നമുക്ക് പിന്നീട് ഡിസ്കസ് ചെയ്യാം. അപ്പം എല്ലാവരും വീഡിയോ കാണുക, മനസ്സിലായില്ലെങ്കിൽ ഒന്നുകൂടെ കാണുക, കണ്ടിട്ട് അത് മനസ്സിലാക്കിയെടുക്കുക. ഓക്കെ, സംശയങ്ങളുണ്ടെങ്കിൽ സംശയങ്ങൾ ഗ്രൂപ്പിലും പേഴ്സണലായിട്ടും ചോദിക്കാം. ഓക്കെ, താങ്ക് യു.